All right, so here we have a software developers planning to launch a new program. The current version of the program could be sold for $100. Okay, and then delaying the release will allow the developers to pack add-ons with the program that will increase the program's utility and consequently its selling price by $2 for each day of delay. On the other hand, if they delay the release, they will lose market share to their competitors. The company could sell a total of 400,000 copies now, but each day they delay, they're going to sell 2,300 fewer copies. All right, so if T is the number of days a company delays a release, write a model P for the price charged for the product. If T is the number of days the company will delay the release, write model for Q, the number of copies they will sell. If T is the number of days the company will delay the release, write a model R for the revenue generated from the sale of the product. And then finally, how many days should the company delay to release to maximize the revenue? And what is the maximum possible revenue? All right, so we're going to do the same thing order here, optimization. Well, for our output, we want to maximize revenue. Okay, that's cool. Now, what is our input? Well, that's T days delayed, okay? Because that's basically, each time of these, T is the number of days that delay the release. So that's what T is. Now, can we draw a picture? I can't draw a picture, but we can write, equations and stuff like that as we go along because it's asking targeted questions to get to the point where we get to D, okay? So first one, I guess we could probably even write it here. If T is the number of days the company delays a release, write a model for P, the price charged for the product. Well, we're going to have some P of T is equal to what? Well, they say we can charge $100, and then we can, if we delay it, we can charge an extra $2 for each day of delay. So plus 2 times each day we delay it. Okay. And so that's going to be dollars per copy of the program. Okay. Now T, again, is number of days that we delay the release. We want to write a model for Q, so we'll have Q of T, and we need the number of copies they'll sell. Well, they said they're going to start selling 400,000 copies if they do it that day. But each day they release, a day later, they're going to sell 2,300 fewer copies. So they're going to subtract off 2,300 copies per every day they delay it. Okay. Now, if T is a number of days, we want to write a model for R. So this is going to be the number of copies they sell. And so our R of T, well, what is R? Well, that's going to be our revenue. So we're going to have to take our P of T times, well, I guess we need a Q of T like that, times our Q of T. And so what we're going to do is we're just going to take this value times this value. So we'll have 100 plus 2t times 400,000 minus 2,300t. Okay, so that's our revenue. So now what we need to do is find out how to maximize this revenue. Well, first of all, let's multiply that out so we know what it is. Now, what is revenue? That's going to be in dollars. So we should probably write that because we had dollars per copy times copies. That leaves us with dollars. All right, so let's multiply those two together. So R of T now is, well, we had 100 times 400,000, so that's going to be 40 and then 000 and then 000. So that should be 4. Okay, so that should give us that. And then we're going to subtract, and then we have 100 times that and 400 times that. And so that's going to be minus 230,000 plus 800 and 000t. And then we had 2t times minus 2300t, so that's going to be a minus 4600t squared. Okay. Now we can add those two together, and if we rewrite this in decreasing powers, it's a minus 4600 t squared, and then 8 minus that, that's going to be plus 57 and 00 t, and then plus 40 0.00000. Okay. Now, this being a negative, we should have something like that, which is going to be max. And is that what we're wanting to do? Yes, we want to maximize revenue. And so now if we take the derivative, that gives us here a negative 9200 t and then plus 570000. And if we set that r prime of t equal to 0, we're going to get 570,000 divided by 9200. And so that's going to give us t is approximately 61.9965 days. Well, we're not going to do days and partial days, so let's say t is approximately equal to 62 days, okay? So that is going to be the number of days it is. And again, I know because I have the negative here, it's going to be a max. It's going to go up and come back down. And so at 62 days, that's where my max is going to be. And so if I plug in R of 62, that will give me what the value is at that max. And so if I plug all that back into my calculator again, this time I'm just going to do it on my hand calculator, 40 million minus plus 570,000 times 62 minus 4,600 times 62. That gives me 576,576,000. Okay, so that is how much my revenue will be. So that's my number of days. That's my revenue at that day. And so how many days should the company delay the release? 62 days. What is the maximum possible revenue? And so that's what zero there, $57,657,600. And that would be how I would solve that one. And again, this one's a little easier because we're just looking at really simple little equations. We end up with a quadratic, which is easy to take the derivative of, and then just, that's a linear equation. So then we can set that equal to 0, solve for t, and we get, 61.9965 days, which rounds to 62. And then we just plug that back in to our original function, and we get out our value for the revenue. All right, so hopefully those will help you get started on these homeworks.